So 319, problem 4 is where we're going to begin. And this is going to be the next section of your homework, the part where you actually have to graph stuff. We have done this before. It's been a little bit since we did it. That's why we're just going back over it. So I'm not going to spend a lot of time on it because, like I said, we have previously done this. So we're going to, first of all, describe the transformations, and then we're going to graph this function. So let's start by describing our transformations. What is this negative sign going to do to the graph? Reflect it over the x-axis. How do we know it reflects over the x-axis and not the y-axis? It's outside. Okay, so if you imagine like you're taking something that's above the x-axis and you're reflecting it over the x-axis, what is changing about that graph? The y values. What's happening to the y values? Their signs are changing. So they're becoming the opposite of what they were before. So I'm going to write out here next to reflect over the x-axis, I'm going to write switch the sign of the y. So I'm just going to write switch the sign of y because that's what we're actually doing. All right, so when we reflect over the x-axis, our y switch signs. And what's the next thing? What's the next transformation that shows up in our problem?
Horizontal or vertical compression of 1/2.
The 1/2. Can't forget the 1/2. And what does that do?
Vertically compresses it.
Vertical compression of 1/2. So I'm going to put VC of 1/2. Okay, so if I take something and I compress it vertically, so I'm making it like shorter essentially, what's changing about the graph? The y's. What mathematically are you doing to those y values? Multiplying by 1/2. Let me write that. I'm going to write y times 1/2. Okay, so I'm multiplying all my y's by 1/2. And then my third and final transformation is -3. Where is that -3? Inside, so that tells us that we're moving it to the right. So we are shifting right 3. Mathematically, if I'm shifting to the right 3 units, what am I changing? The x's, and I am adding 3. So I'm going to do my x's plus 3. So we're going to take all these things that are written in the parentheses on the end, and we're going to actually do them to our table of values. Do we already have a table of values for our cubic function?
Yes.
Yes, we made one yesterday. We made one that was on our cubic functions reference sheet that we made. So I'm just going to use, because I'm looking at my graph over here, and my graph is kind of small. It doesn't go anything past -4 or -5 and +5. So I'm going to use for my table of values just 5 numbers. I'm going to do -2, -1, 0, 1, and 2. If those are my x values, and my parent function is f of x equals x cubed, okay, remind me of my y values or my f of x values that correlate with that. If x is -2, what is f of x?
8.
-8, because there's just -2 times -2 times -2. When x is -2, f of x is -1.
Oh.
Did I say -2? Oh, I'm sorry. So I meant to say if x is -1, then f of x is, that makes sense, -1. There we go. If x is 0, then f of x is
0.
And then for 1, it's 1, and 2 is 8, which we already done the math on that, just different signs. So I've got all these. Now I need to do what I said I needed to do. So the very first transformation we wrote was what? Switch the signs of y. And why are we switching the signs of y? What told us to do that?
The negative sign.
It's reflecting over the x-axis because it was negative. So I'm going to switch all my signs of y. So my negatives become positive, my positives become negative, and I have taken care of my reflection over the x-axis. Okay. What was the next transformation that we had? The vertical compression, which said we need to multiply all of our y's by 1/2. Multiplying by 1/2 is the same thing as doing what?
Divided by 2.
Yeah, negative or positive 8 divided by 2 would be 4. 1 divided by 2 is 1/2. 0 divided by 2 is 0. 1 divided by negative 1 divided by 2 is negative 1/2. And negative 8 divided by 2 is negative 4. Okay, so that takes care of my second transformation. My third one said shift right 3, and you guys told me I needed to add 3 to all of my x's. So that's the final thing that I'm going to do, and then I will get my new graph. So negative 2 plus 3? 1. It's okay. Happens. We're good. Negative 1 plus 3? 0 plus 3? There we go. 1 plus 3? And 2 plus 3? Okay, and we're going to plot all of those points. So those are our new ordered pairs that we're going to plot on our graph. Now, did y'all get them written down? All right, so what was the first point that we had? 1, 4. All right, so 1, 4, not there, here. Okay, where was the next point? 2.5. And then 3, 0, I think. And then 4, negative 0.5, and my final point? 5, negative 4. So that gives me enough to get a general idea of what the graph looks like. So this would be my new graph. I'm just going to go through this and actually write down what all these things mean for us to do. Like starting with, let's start with D. If I'm shifting the graph up or down, what am I actually doing to my numbers?
Adding or subtracting.
Yeah, you're adding or subtracting to Y. So that's what I'm going to write in here is like what's happening. So if I have D and I'm supposed to either shift up or down, then mathematically what I'm doing is my Y is either plus or minus D, whatever that value happens to be. And again, you can either take a picture of this when I'm done or you can write it on yours. It doesn't matter to me. But I thought that would be a good thing for us to go through and just review since it's been a while since we did this. Okay. What about C? What does C do to the graph? Yes, it's X plus or minus C. But remember, it's the opposite, isn't it? So I'm going to write X minus or plus C. So that tells me, hey, I'm doing the opposite of, whatever it says. Okay, and then we're going to look at B next. Or do y'all do A next? Which one? B. Okay. All right, so B, the horizontal stretch or compression, mathematically, what do I do with my horizontal stretch or compression? X, I multiply by the reciprocal, so I do X times 1 over B. Whenever you see 1 over B, what that means is that means the reciprocal, okay? So you can write X times the reciprocal, or you can write X times 1 over B, or write that 1 over B is the reciprocal, something like that, whatever you might need there, because these are yours to keep. What is the negative B? That reflects over the y-axis. If I reflect something over the y-axis, what's changing about it? The X values. So the negative B part tells me to switch the sign of X. The negative B part tells me to switch the sign of the X's. And our last one is A. And we just did one of these because we had an A value in our last problem. So what do I do with the A value? If I'm vertically compressing, what am I doing mathematically? My Y's times A. So my Y is being multiplied by A. And then if A is negative, it reflects over the x-axis, which we said a second ago meant that we're going to switch the sign of Y. So that may come in handy just to have that information written on your paper as you go through and apply these transformations. So problem 6, a general equation for a cubic function g of x is given along with the function's graph. So here's our graph. Write a specific equation by identifying the values of the parameters from the reference point shown on the graph below. Basically, we're trying to figure out what's the equation of this cubic function. So they've given us our equation here that we're supposed to use to help us out. So we're doing 6 because 6 is harder than 5, I can tell you that. So if you can figure out 6, you can easily figure out 5. And so it says g of x, which g of x is the same thing as what? F of x or y, equals 1 over b times x minus h cubed plus k. So I have some points here. We normally start off, we've done these before. We've done this with quadratics a little bit. Normally we start off with h and k. And what is hk typically? The vertex. Well, this problem, these cubics we talked about yesterday, don't have a vertex. So what do you think they mean by hk? Yeah, it's that little center point thing where it starts changing directions. Where it changes, I think the word we talked about yesterday was it changes concavity. So hk is 1, negative 1. Which of those is h? The 1. When I plug it in here, the first one is. When I plug it in, what happens to it? What does that minus h tell us? It changes sign. So it'll be negative 1. Let me try a different pen that's not as thick. So it'll be negative 1 here. And then k will be a, what is k in this problem? Negative 1. It's also negative 1 because it was by default actually negative 1. Fill in some parentheses. Okay, what else do I know?
That's a good question. The 1 over b.
Do I know 1 over b? Do I know an x and a y?
Yeah.
How many x's and y's do I have? I actually only have 2. Why do I only have 2? Why don't I have 3? I already have h and k as this point, the 1, negative 1. So now I have 2 ordered pairs that represent x and y. So I need to use one of these. Does it matter which point I use? Which point would you rather use? I would rather use 5, 0 as well. 0 is a much better number than negative 3 and negative 2. So if we can opt for anything with 0 and 1, that's always the best bet. So for x, I'm going to plug in which of these numbers? 5. And then for y, I'm going to plug in 0. So I took x and y, or x and g of x, came from this ordered pair here. And now I just get to do math. And we all know how much y'all love doing math.
Yep.
Yay! It's so fun. Let me rewrite it. 0 equals 1 over b times 5 minus 1 cubed. Close that again. There should be 2 parentheses there. Sorry. Minus 1. Order of operations. What do I do first? Parentheses. And that means inside the parentheses. I need to work out what I have inside the parentheses. So like looking in, I have 2 sets of parentheses. I have 1 over b times, in parentheses, 5 minus 1. So what is 5 minus 1? 4. Okay. So now it's 0 equals 1 over b times 4 to the 3rd power minus 1. Can I actually multiply 1 over b times 4? I could make it 4 over b. That's not terrible, is it? Okay. That actually sounds pretty good to me. So 0 equals 4 over b to the 3rd power minus 1. I'm solving this for b, so what do I do?
Plus 1.
I need to get rid of the 1, and to get rid of the 1, I'm going to add 1 to both sides. So 0 plus 1 is 1 equals 4 over b all to the 3rd power. I need to uncube it. That would be called cube rooting. Okay, to write a cube root, we write a square root, but instead of having no number, it has a little 3 there.
Oh, that's what those are?
Yeah. Did you know that by default, in a square root, totally random side information, in a square root, there is an understood 2 there. That's what that implies. So when you have a cube root, you just put a 3 there. So what's the cube root of 1?
1.
Yeah, that was easy enough. Not terrible. So I know that 1 equals 4 over b. So the question is now, how do I find b? How many of you love fractions? I know you love fractions so much. Here's the thing. As much as you hate fractions, when you have problems like this, having two fractions is better than having one. Just like the Bible says 2 is better than 1. Same thing is true with fractions. Because when you have two fractions, you can cross multiply. So b equals 4.
Couldn't you have just done like inverse?
Yes. That would have worked as well. So, but I wanted to make sure I talked about the fact that two fractions is better than 1. Really, because I just like fractions. So, I know. So my real equation, my final answer to this problem would be g of x equals, so I'm just going back up here and looking at what it said. It said 1 over b, but we figured out that b was what? 4. So 1 over 4 times x minus 1 cubed minus 1. Oh, that moved. I didn't mean for that too. That's okay. Minus 1. That is our final function. Remember, when we're writing our functions, we want to write it so that it's usable to describe the whole function. That's why we leave x and g of x there, because that means it represents all the x values, not just an x value. If we wrote this out and plugged again 5 and 0, then we're saying it only represents one point, but it doesn't. It represents every point. So that's why I use x and g of x. So just as a reminder, your homework 2 through 15, I already gave you that part yesterday. You're describing the transformations. And then 16 through 17, you're describing the transformations and you're graphing those. And then 18, 19, those are the two you're going to have to solve like we just did. And then 22, 24, and 26. This is your assignment, and this assignment is due on Monday.
And I go get some water.